Hello, my name is Daryl Shirley, and this is my Lab 6. Introduction. In this lab, I will be going over the purpose, main ideas, fundamental physics principles, systems and surroundings, preview, experiment, glow script, model, possible errors, questions, and conclusion. Purpose. The purpose of this lab was to analyze the motion of a magnet through a conductor and create a model that predicted this motion. Main ideas. The main idea of this lab was to use Faraday's law and our current understanding of physics to create an accurate model of a magnet passing through a conductor as it is experiencing the first force of gravity. Fundamental physics principles. The fundamental physics principles that were in use during this lab were Faraday's law and a magnetic field created from a dipole with a magnetic moment at an observation location, as you can see below. System and surroundings. System. The system of this experiment is the magnet. Surroundings. The surroundings of this experiment are as follows. The aluminum foil conductor, the earth because of its gravity, the hand dropping the magnet, and the table the magnet lands on. Preconditions. The preconditions of this lab are as follows. The resistivity of the aluminum foil, which is 2.68 times 10 to the negative 8. The length of the aluminum foil, which was 0.45 meters. The width of the tube, which was 0.005 meters. Acceleration of gravity, which is 9.81, u naught over 4 pi, magnitude of the magnetic dipole of the magnet, which was 0.2, and mass of the magnet, which I found to be 0.0728 kilograms. Preview. In this lab, I will go over the experiment, the glow script code I created to model the motion of the magnet through the aluminum tube, the model created from that code, possible errors I could have encountered, what if and what does it mean questions, and the conclusion. Experiment. To the right is the experiment we conducted in which we drive the magnet through the aluminum foil tube. Glow script. To the right, you can see the part of the glow script code used to create the computational model. I input the preconditions and used the physics equations for the magnetic field created from a dipole moment. I also used Faraday's law to calculate the magnetic flux, current, and eventually the magnetic force on the magnet opposing the gravitational force. To the right is the continuation of the code where I eventually calculated the time it took for the magnet to fall all the way down through the aluminum tube. Computational model. To the right is a video of the computational model in motion in which it shows the magnet falling through the aluminum tube. The time it calculates it takes to fall is 0.279 seconds.
Build for a very small time period, you can say approximately it's going straight. Yeah, I see what you're saying. It's not a time stamp where it's not. It's only and what is going to happen here?
Similarities between model and experiment. The model and experiment experienced a very similar motion in that the speed of the magnet was slowed by the induced current caused by it falling. The difference is in the time it took for the magnet to fall, because during the experiment, it took an average of 0.5 seconds to fall, while for the model, it took 0.279 seconds to fall. Errors and possible explanations. The possible errors that could have occurred during this lab are as follows. I didn't account for the air resistance or drag force that the magnet could have experienced when falling through the aluminum tube. My magnitude of the magnetic dipole moment could have also been incorrect as a precondition. I also didn't account for possible friction that could have occurred during the fall of the magnet. Questions. What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? The falling magnet would have a faster speed closer to the speed it would have been caused by gravity. What if holes or slots were cut into the tube? How would this affect the ring currents in your model? If there were holes cut in the tube that would reduce the overall resistivity of the conductor, which would cause a lesser induced current and decrease the magnetic force pushing up against the magnet as it falls. Therefore, the speed of the magnet would increase. Conclusion. In conclusion, during this experiment, we used Faraday's law and the equation for a magnetic field created from a dipole with a magnetic moment. I went over the preconditions, experiment conducted, glow script code, computational model, similarities between experiment and model, possible errors, and questions. The end. Thank you for watching.